ஜி அந்த மெயிலில் யூடியூப் லிங்க் வந்துருக்கும் பாருங்க, அதை செக் பண்ணுங்க, லைவ் ஆகுதாங்க. சார் நீங்கள் போங்க சார், நான் எல்லாருக்கும் அனுப்பிச்சிட்டேன் சார். On the way, I was traveling. But while taking picture, that I created. That we can create.
I thought like you were somewhere. So you I thought to attend that. You have to create, huh? From where? Google Meet.
In Google Meet.
How?
There is no option.
You can show me now. No, it's not possible. YouTube. Now it's switched off.
Yeah. Already.
நீ வீடியோ ஆன் பண்ணியா? வீடியோ ஆன் பண்ணியா?
Okay, sir. Yes, sir. Yes, sir. That's the correct one. Actually, this Google Meet is only 150 is accepting. So if you join Vivo Excel, it will be good, sir. I'll just participate in that. Okay, sir. Right, sir. Okay, sir. Okay, sir. Yeah, sir. Sir, I will just introduce you, and the HOD will just give you a call, and then your decision will be handled. Yes, sir. Swapnil sir, very good evening, sir.
Good evening, sir.
Good evening, sir. Welcome to the section.
Yes, good evening, ma'am. Good evening, all the participants for joining this webinar.
Good evening, sir.
Sir, we 2 more minutes, sir. Exactly by 6 we can start.
Yes, sir, sure.
Very good evening to all. I welcome you all for this electromagnetic simulation using TARANG webinar on behalf of KISS College of Engineering and Technology, Department of ECE, IEEE and IEEE MTTSS, MTT Society. So I am very much delighted and happy to by welcoming you all for this wonderful webinar by Swapnil sir. Now I welcome our department, head of the department, Dr. C.H. Seema Bettu madam, to provide an introductory speech. Ma'am.
Yeah, thank you, Dr. Jones, sir. So, good morning. Good evening to everyone. So, it's very hard time, but as academicians, we are always ready to learn the new things. So, on behalf of KISS College of Engineering and Technology, so Ongol, Andhra Pradesh, and in association with the IEEE MTTS SBC 18211, we are the Art in Hyderabad section. So, under MTT platform, we are conducting, this is the first event, so I'm so happy. So I want to hearty welcome to the Swapnil Gaul sir, so to give the webinar on the electromagnetic simulation using TARANG. And in our Prakasham district, we are the first autonomous college. We have the NAC A+ grade and thrice accredited by the NBA and other credentials also there. And one more important credential is our college is having of NIRF rank in the band of 200. And recently, we received a lot of awards by the worldwide recognized body also. So I'm happy to introduce about my college. And coming to the department, our department of ECE is actively having of one of the international recognized society, that is IEEE. Under this IEEE, we have two chapters and one affinity group. Recently, we inaugurated two chapters also. One is MTT and Computer Society, and second one is the affinity WA affinity group. And earlier also, from past 1.5 years onwards, we are actively doing all the activities under the student branch. But now we extended our hands by adding of new chapters. So I am happy to share that the Swapnil sir, yours is the first event under MTT chapter. So we are very fortunate to have you, because everyone as an academician, we are always trying to learn the new things in every day in our lives. So this is a very new platform, that is electromagnetic simulation using TARANG is. So everyone is very eager to learn the things. So now the platform is yours, and thanks for accepting our invitation in a single notice. And now I think the joiners will enjoy your session, sir. Thanks.
Thank you, madam. Swapnil sir, your mic is muted.
Yeah. So, thank you, sir. Thank you, ma'am, for the kind words. And I also want to congratulate the institute, the department, MTTS chapter, for having this activity. And we are also happy that we are the first person to be part of this activity. So it's like proud moment for us also. So thank you.
Exactly. Thank you, sir.
Sir, Supply sir, I will just introduce you,
Yes, sir.
and then the session you can take the session. 2 seconds. So I am happy to introduce our guest
Yeah, I
speaker.
request Dr. Jones, sir.
Ma'am?
Yeah. Please
Yeah,
proceed. Sorry.
sure. So I am happy to introduce our guest speaker, Swapnil Gar. He completed his masters from IIT Kharagpur in 2011 to 30, and his specialization is microwave. And he completed his project in computational electromagnetics and numerical techniques under the guidance of Ramesh Gar. After his masters, he worked in NI Logic for simulation software and EDA tools, including FECO, ESISM, Solution, and QuickFields. And he demonstrated various softwares or more than 75 engineering colleges across India. And he did his research he did simulations to various research organizations like ISRO and DRDO. And then while demonstrating the softwares to the undergraduate, he realized many students are not comfortable in using the simulation softwares, and there he gained the spark of generating an electromagnetic software that is nothing but the TARANG software. After getting adequate industrial experience, he quit the job, and then he developed his own package, and it is now funded by DT, Department of Technical Education, Maharashtra. And TechUp funding is also under TechUp funding. He is having some funding also. And the list of institutes he visited for the software demo is IIT Kharagpur, IIT Kanpur, IIT Mumbai, IIT Varanasi, IIT Indore, IIT Jodhpur, IIT Ranchi, IIT Allahabad, IIT Nagpur, NIT Jamshedpur, VIT Nagpur, MNIT Allahabad, AMU, BITS Bilani, BITS Jhansi, VJIT Mumbai, GEC Aurangabad, PICT Pune, and QSAT Kochi, and GCE Karnool. So this is the short introduction about Swapnil Gar sir. So thank you for accepting the invitation. In your busy schedule, you accepted. Thank you very much. The session is yours, sir. Thank you.
Hello. Yes. Thank you, sir, for your kind introduction. And thank you all the participants for joining this webinar. So in this webinar, we are going to see a different thing, like a new thing. Most of the participants might not have heard about Tarang simulation software. So for them, we are going to introduce Tarang simulation platform. So we have introduced this platform very initially in IIT Kanpur during 2019, means something around pandemic time. And then in the lockdown, we had several webinars on this particular software platform. But later on, we had like offline trainings. Many activities happened later on. We had research activities. We have educational activities. So I have been working as a syllabus coordinator for many institutes. Syllabus coordinator for many institutes as an advisor, where my duty is like to make the electro. So that things we are also doing. And apart from that, we promoted Tarang software. Tarang is like India's first simulation software in the area of electromagnetics. In 19, it was like a small version, but now we have expanded a lot of facilities into the software. So when we launched it, initially it was only for linear antennas, but now we have a lot of features like planar antennas, MIMO antennas, metamaterials, and in the basic also we have basic electromagnetic, Coulomb's law, Faraday's law. So we have divided the software into two parts now. Earlier it was only one software, but now when we see that the software is becoming very big, we divided the software into two parts. One is basic electromagnetic, second is microwave design and antenna. So in this way, this software is evaluated into a new version, which is having two parts in the software, two different simulation packages, which are going to cater the need of UG as well as PG and PhD students. And we are also becoming part of different research conferences like INCAP, IMR, and we are like supporting partner for ATMS. So ATMS is going to be held in Mumbai in July, and we are the technical partner for ATMS. We are promoting this conference, and we are also promoting the research in the area of antenna and test and measurement. So in ATMS, we have launched an initiative where we are providing free access of the simulation platform to some researcher who can publish their paper. So that activity also we announced last week, and we got many registration for that. Around 87 registrations we got, who want, like the professor who want to use Tarang software free access, and want to get paper published in the ATMS conference. Similarly, in the next after ATMS, we also have our technical partnership or sponsorship, we can say, in MAC conference, MNIT Allahabad. So there also we are going to do a lot of activities. So we performed many activities during corona, after corona, and recently also we have presence in mostly all the research conferences happening in India as well as international conferences, and we are supporting many institutes to make the electromagnetic course more hands-on based, more interactive. We are promoting the institutes to make microwave research lab facilities, simulation techniques, as well as fabrication support also we are providing through our third partner, third channels, and there are also some facilities of measurements that we are also going to provide to many of the institutes, demonstrating the software solutions and all. So I will share this Tarang and what are the two modules available in the Tarang software. So I will share the screen. Sir, I guess screen sharing is disabled.
Just a second, sir.
John sir, can you check it
Yes.
once? John sir, are you there?
Yes.
Yes, ma'am, I am checking.
Yeah, 1 minute, Swapnil sir.
Your screen.
Sir, Swapnil sir, can you check now?
Yes, sir. So welcome back once again all the participants, and here I'm sharing some slides on this New Meridian's Tarang platform, which is like India's first simulation platform developed for the electromagnetic subject. So my name is Swapnil Gaul. I'm founder of New Meridian Pune, and my mail ID you can note down, swapnil@newmeridian.com. So basically, in New Meridian, we have developed this Tarang into different level of subjects. So most of the undergraduate students are aware about drag and drop kind of designs to make the circuitries. So there is like one package called as Tarang Circuit Design Package, where we can directly put different resistor, inductor, capacitors, and create different circuits. We can do transient analysis, DC analysis. Along with this resistor, inductor, capacitor, there is also feature of dragging and dropping microstrip components like bend, tease, discontinuity, step discontinuity. So many discontinuities we can drag and drop and create any circuit, and we can run at high frequency, like S parameter simulation is also possible in circuit design. So something like ADS software, we can drag and drop different microstrip components, and we can create the high frequency circuit. So basically, the circuit design package is going to cater the need of low frequency simulation as well as high frequency simulation. Then the second package, which is unique of Tarang, which is basic electromagnetics. So there is no alternative to basic electromagnetic solution of Tarang. So Tarang is the only solution by which you can do your comprehensive electromagnetic simulation. So in this particular package, we are having basic laws like Coulomb's law, Biot-Savart law, charge dynamics in electromagnetic field, polarization studies, waveguide modes, and so on. And then after studying these basic electromagnetic concepts, it is advised for the students that they can go some little bit in advance, because basic circuit mostly all electronic students do. When it comes to electromagnetics, most of the UG PG students feel it is difficult to understand the concept, because there is a lot of mathematics, there is a lot of visualization, there is a lot of imagination required to understand basic electromagnetic subject. So for this need, we have made a package by using which it will be like easy to understand the subject. And after understanding the subject, next step will be to apply some research knowledge to it. So we are having a microwave design package for that. So when we have this mostly all kind of complicated problems like biomedical problem, bioelectromagnetic problem, then radar problem, antenna design problem, microwave circuit designs, filters, couplers, microstrip antennas. This kind of like different antennas, circuits, radar. This high-end microwave design can be solved by using this third package. So today we are going to discuss the two packages, basic electromagnetic package and microwave package. And I am going to focus more on the basic electromagnetic part, because based on software, our basic offering is basic electromagnetic, and microwave design is the add-on on the basic electromagnetic. And as basic electromagnetic, for basic electromagnetic, there is no other alternative. We are going to focus more on this basic electromagnetic part. However, this microwave design, you might have seen some other tools are also available similar to microwave design of TARANG, like CST, HFSS, FICO, and so on. So you have idea about what microwave design package does. So the basic electromagnetic is the thing which makes this solution a complete solution. So when we talk about basic electromagnetic, we start from coordinate system. Like we can take a point in a particular coordinate system, we can convert that point from like rectangular to circular, rectangular to cylindrical, cylindrical to spherical. In that way we can make coordinate system conversion, and we can visualize that how that particular. Then there is a area of vector calculus. So in the vector calculus, we can create 3D field, and after creating a 3D field, we can compute different operations like curl operation of a 3D field, divergence operation, gradient, then line integral, circular integral or contour integral. Then we can also perform surface integral, volume integral of that particular field inside a given solution space in 3D. And it is not to compute these integrals, but we can also visualize how that particular field will look. After that, we have Coulomb's law. So basically, the Coulomb's law, we know that there are 2 point charges or multiple point charges, and we can calculate the forces between the point charges. So that's like simple simulation approach for Coulomb's law. But there are also some advanced simulation option. Like we can create charges, we can have any kind of shape, circular surface, rectangular surface, any shape we can take, any dimension we can draw, and we can calculate the electric field generated by different surface charges. Then after surface charges, we also have different volume charges, line charges, and then we can again find out the integrals of those charges, electric field generated by those charges. And there is also charge that we can draw distributed charges. Like if there is an equation for a particular surface, then how that particular equation based surface can be modeled and can be computed. So that study also we can do. Then in Biot-Savart law, again the same thing. The velocity of attraction, like different charges, and if there are current carrying conductor, what time that particular charge will be at which location, that kind of problem we can solve, and we can verify that particular trajectory data and all with the TARANG simulation platform. After that, we also have waveform generator. So in the waveform generator, we can generate different kind of signals like EX polarization, EY polarization, EX and EY both. We can put that signal generator at any location, and we can find out the superposition of those signals. Particular signal gets transmitted into a certain media, and what happens, how that particular reflection phenomena happen, that kind of studies when a particular signal hits on a particular dielectric or any media. There are different types of mediums like lossy dielectric, then simple dielectric, anisotropic dielectric. So there are like different materials, and we can study what happens when a EM wave hits on that particular medium, how it gets transmitted, reflected, absorbed. This kind of things we can study with the help of animation. Evidence is also there in the software, like when we are having a signal incident with 10-degree angle, then planar antenna, deformed ground structures, dielectric resonating antennas, implantable antennas, MIMO antennas, 5G, and so on. And then there is RFIC, MMIC, power divider, ring resonator, filter, rat race coupler, so on. Metamaterials, electromagnetics, and SAR analysis, static and dynamic RCS analysis. And we have uploaded a lot of videos on our YouTube channel as well as on our web portal, where student can perform a lot of experiments by seeing the videos. They can simulate different antenna design. So basically there are three subjects that we can cover by using the software. First subject is the electromagnetic. So when we talk about electromagnetic, this software is going to cover complete electromagnetic syllabus, 80% content of. So electromagnetic concept basically not covered by most of the software, but Tarang is able to cover basic electromagnetic concept, and after that book concept, which is like antennas, and then DM Potar book, which is for microwave circuit design. So these three book simulations completely you can do in Tarang simulation platform, and after that if you have any other simulation, those simulation can also be performed. How this software UI looks, what are the different features in the software, and how we can use this software for studying and learning basic electromagnetic. So when we open this particular EMF package, it is written that Tarang EMF is computer-based simulation platform built based on computational electromagnetic. It's a blend of mathematical modeling and its representation using 3D visualization. So the visualization provided in Tarang software is very much advanced, thus providing firm grasp of electromagnetic fundamental using hands-on practices through unique and comprehensive collection of simulation exercises. So the main intention of creating this EMF package is that, as we know that most of the students are not easily understanding this subject, electromagnetic, and even most of the faculties are also not able to teach this subject very effectively because it's difficult to explain the relation between the physical terms and the mathematical terms. And even if we explain, it is difficult to imagine again. So because of that reason, we created this platform so that student, it will be like useful for student to imagine these concepts. So first we'll go to this coordinate system, and we can see okay. So this software is like cloud-based software. So it takes the information from the internet and then it gets that. So when we have this x is equal to 50, y is equal to 50, and z is equal to 50 point in the rectangular coordinate system. So this point will look like this, x, y, z. And when we move this particular point at how that particular point will be shifted when we change x, y, z. Along with that, we can also see the conversion, cylindrical conversion and this spherical conversion. So this is like first experiment, which is like very basic experiment to understand this spherical coordinate system, cylindrical coordinate system. So in the cylindrical coordinate system, there are three parameters, rho, phi, z. So when we change the rho, the point is going to move in this way. This phi angle. When we change the rho, that radius of the cylinder is going to change. And when we change the z, the height of the cylinder will change. It means the point will shift up and down. And when we see the spherical coordinate system, r theta will change, and by changing z, phi will be constant. If I change the z, phi in the spherical is constant, but in the cylindrical, z is equal to z. Means rectangular coordinate system z value is equal to cylindrical coordinate system z value, and object into 3D space. So most of the student, it is like difficult to understand 3D coordinate systems, drawing the 3D object, and this is the knowledge which is like very basic required for drawing any 3D shape. So this particular tool is going to make aware about how to draw different 3D objects like brick, box, and so on. Like if I want to draw a box, then the box will have this minus 25, like this coordinates: start point, end point, dimension, so length, breadth, and height. So student can practice these drawings how they, let's say minus 25, this 50. In this way, like we can change the color, and we can draw different boxes. Or there are different shapes we can draw. We can change the transparency also. So once we draw this object, how that object will look into 3D, and then suppose we also draw a line. So this is like getting idea of basic vector algebra or basic electromagnetic vectors in that second chapters of the Sadiki book. If there are two lines in 3D space, so check whether those are that line, and we can check whether that two lines will intersect or not, or what will be the length of the line. So we can also have option like assign computation. We can select second board object also, assign computation, compute. So now we can see the length of line here. Length of line is 8.39 10 to the power 1. And for this line, the length is equal to 45.36. So how that length is calculated? So we can do like x minus y and all that calculation, and we can get to the length. So student can verify that differential length, differential area. For example, if we draw a circle, then for circle what will be the area? So that thing also we can calculate. Assign computation, compute. So the area, surface area of this circle is 8.29. So student can draw different shape as per their need. At any location they can draw the circle, and then they can find out the area, length, and other parameters, just to get idea about how the vector algebra and how the 3D object, differential length, differential surfaces, differential volumes are going to work. So this is just an experiment to get idea about this 3D object, but this experiment is going to be useful in all other electromagnetic simulation. So next is vector algebra, where we are going to perform different vector operations. Like we can take a point, we can have two vectors, and we can draw superposition of the vectors, subtraction of the vectors. This basic experiment in the 3D space we can do, and we can demonstrate to the student like what will be the curl operation or cross product of two vectors. So yes, so this will be the cross product, and when we change any of this vector, the cross product is going to change. So cross product will always be orthogonal to both the vectors. So this way we can teach this addition, subtraction operations. Then there is vector field. So yes, so from vector field, the advanced concepts are going to start. So earlier 3 experiments are very basic experiment, just to get idea about how this basic vector algebra and basic point, basic 3D object, length and other parameters. But here we are going to do vector fields, how the vector fields will look. So if we have equation minus 2y ax plus 2x ay, then how will be this vector data look like? So we can see that this is in the form of circle. This particular 3D vector equation is there. So this vector will look like this when we plot in the 3D space. So suppose we want to perform any operation of this vector field. So I can turn off and turn on different plots. Suppose I want to calculate the vector integral on a circle. So this is vector field given like circle, like this. And now after drawing circle, we will compute surface integral. So this vector field, the surface integral, we need to select, right click, assign computation, compute. So the surface integral is 0. The reason is that vectors are in the round direction and the normal is in the z direction. So the normals are orthogonal to each other. So ds and these two vectors will cancel out each other, the product, because they are in the orthogonal direction. But when we calculate the circulation of this field, so the circulation of the field will give us the integration value. So 45.07. The line integral is 0. And when we see the line integral, here it is 39.51. So when these two circle will become of same dimension, so in that case we can verify that curl of vector on a given contour is equal to surface integral circulation over the surface of the same dimension. So that Stokes theorem can be verified by using this particular tool. We can also calculate the field at any point. So let's say I want to calculate the field at this given point. So I will click on compute again. So the field at this given point is this one. I will turn on the arrow. Yes. So yeah. So we can see the field data at point given, or we can change this point location and we can calculate the field at given point. Suppose we want to perform curl operation. So what will be the curl of this vector field on given point? So we'll compute. So we can see that now the direction is changed. It is in the z direction. So the curl will be 4 in the z direction, because here it is 1. So when we draw the curl of this particular field, it will be like in the z it will be 4. Again, we can disable or enable different plots. Even we can calculate the gradient in the x direction, gradient for y, gradient for z, divergence. So we can calculate anything for like curl, divergence for given vector field. Suppose I want to make this like x square. So yeah, so the circulation of x square will look like this. And the data for this particular equation, yes, so this is the data. So we can change any vector equation, and for that vector equation we can visualize how that particular vector equation will look and what are the different integrals. field. So this is the vector field, and different properties of that vector field can also be computed. We can see the arrows, we can see the contours. So after understanding this vector field, we will next move to the Coulomb's law. So in the Coulomb's law, there is possibility that we can compute the electric field in different cases. Like if I put a particular point charge at location 1, location 2, I will double click. We can change the location of point charge anywhere we want, we can put. So let's say one charge is of 1 coulomb, second charge is of -1 coulomb or -2 coulomb. Then what will be the electric field? So we'll compute the electric field and we'll plot it now. So the electric field will look like this. So what will be the force at a given point? So that thing also we can calculate. So suppose we want to calculate a force at given point P. So we'll take this point. Assign computation. Compute. Yes. So we can see that this particular charge which is here is -2 coulomb. So the field will be from positive to negative. So we can also see the arrows. If we zoom, we can see these arrows. How field will be. So it's basically positive to negative. We can again take many number of points we want. There's no restriction in the software. We can take any number of charges, we can take any number of points, and we can verify these dimensions, and we can verify all the result. Suppose there is one more charge. This is, let's say, 1 coulomb. We'll compute. Yes, now we can see with one charge it is having attraction, and with another charge it is having repulsion. So this can also be visualized by using the contour map. So these contours. Suppose if I change this value to -3, now we can see. So this is about the point charge, but we can also have a line charge, then different shapes also we can take. Or if we want to do calculate the integral curl on a given loop. Suppose this is the loop, and I want to calculate E dot dl on this particular loop. So I will select right, assign computation, compute. Yes, so now we can see the value of E dot dl. So integration is like 8.18 10 to the power 5. We can also calculate E dot ds on a given surface, or we can take different line and we can convert it into line charge. Let's say this is the line. I will assign as source. So when you want to make it like line charge, I will enter the density of this particular line. So yeah, so when this is the line charge and when there are point charges, then this particular field will be looking like this. we can also draw the surface charge. So again, in the surface, it can be rectangle, circle, anything. So any shape we can draw. After drawing it, we can select, right, assign source, and then value. So value can also be in the form of equation. So I want a surface to be of equation. Then we can also specify the equation. Let's say x square or y square or anything, like we can draw any complicated equation here. So how will be the field lines? So now this is the field line created by this particular surface. Again, we can draw another surface, negative charge. We can apply, and then we can calculate the capacitance between these two surfaces. So to calculate the capacitance, we assign as a computation. We will calculate E dot dl, and we will get that value of capacitance. So let's say it is negative x square. Compute. Yes. So this is the charge distribution when there is rectangular plate and the circular plate. So for teachers, it will be like easy for to demonstrate the parallel plate capacitor concept. If there is one plate positive charge, another plate negative charge, then what will be the capacitance between that plate? They can take any dimension of that plate. They can double click, change. If one plate is rectangular, another plate is circular, then what will be the capacitance? That type of concept we can. So the next simulation is boundary conditions, electrostatic field in different dielectric or at different boundaries. So here we can like draw a particular, like take a particular charge, and we can calculate the field, and we can change the boundaries, solution boundaries also. Like there is one button called as this boundary condition. So yeah, we can have different boundaries like open, PMC, Dirichlet, Newmans. So by default, like this Dirichlet boundary condition is selected. So all these boundaries of this particular solution box are Dirichlet. We can also make Newman's boundary, and we can see the difference. What happens if we solve this particular problem by using different boundary condition? So for Dirichlet boundary conditions, this particular solution will look like this. We can again double click, change the value, 5 coulomb. Wire element, let's say 2 is the diameter, and on this particular wire, if we apply a current source, or I can change this dimension also. I'll double click. So 0 to 4p, and this 0 0 0 0. So if this is the conductor, and if we apply a current source on this conductor, then how will be the magnetic field? So we can take this as a current source. So this is the current source having amplitude is 1. Compute. Assign as wire. We'll apply current. We can also check this contour maps. So there can be like any kind of combination. We can have any number of current carrying conductor, any value we can put, and we can calculate the field, magnetic field generated because of those conductors. And we can also calculate the mutual inductances between the different conductors. After that, types of medias. So for example, let's say if I have a point charge, I will assign a velocity to this particular point charge in x and y direction to move in this way. Suppose there is an electric field. We can play and signal generator at let's say the distance is 30 and assign waveport in the same okay, I'll change the dial, I will make EX and then compute. Yeah, so in this way we can perform polarization. Again, if I want to change the location, then I can again change the value of Z. I will draw the signal generator once again. Assign waveport. I'll make both the components EX and EY11. So now we'll see. Yes. So this is linearly polarized signal. So when we want to study different materials, suppose what happens to the signal when it goes into anisotropic material. Anisotropic material means the material which has different properties in EX direction for EX signal or for EY. Means in the orthogonal direction, the properties are different. So suppose I add this particular block at some distance. I'll make somewhat transparent. So we'll select it and assign as a polarizer. So there are different options. Assign as sheet. If we make assign as sheet, there are different electromagnetic options. Perfect electrical conductor, perfect magnetic conductor, impedance boundary condition, then resistive sheet, magnetic sheet. Again, in the solid also there are different operations: simple dielectric, lossy dielectric, anisotropic dielectric, magnetic material, resistive material, general material. So we can take any material properties and we can see what happens when it goes under different materials. So right now I will make it as a polarizer. So the speed for EX is 3 into 10 to the power 8. Speed for EY, let's say instead of 3 into 10 to the power 8, we'll make 2 into 10 to the power 8. So it will behave as a anisotropic material. Now we can see how this particular signal will propagate. So this is the transformation from linear to circular. We can also check in YZ, XZ, XY plane. So here we can see it is kind of circular. And there is also a lot of experiment we can perform on this. Left hand circular, right hand circular. So this is currently left hand circular. We can see that these arrows are rotating in the leftward direction. If you want to make right hand circular, then what will be the values? So student can calculate that values and try to make it right hand circular. Or it is completely not circular, it is elliptical. So when we want to make it complete circular, then what value of that particular velocity or box dimension will be. So that type of experiment student can perform. So let's see the height I will assign as a variable h. So this is changing from 50 to 100 with step size of 2 and default value let's say 50. So slab height or slab length. So now here we can see if slab length changes, what happens. So we will compute. So if I increase the slab length, we can see the result is also changing. So we can perform different experiments on this particular tool to see what happens when we change the slab length, slab height. And these changes are happening very live. Means I just change the slab height and in the live demo I can see how the result is changing. So the computations which are performed in the software are very fast. Then different experiments are also there, like plane wave under different media. So here we are going to see what happens when the wave hits a particular media, how the reflection happens, how the transmission happens, and so on. We'll make a signal generator at any point. So there is no restriction in the software. We can have any number of signal generator, we can have any dimension, we can have any material property, and we can simulate it. Solid dielectric, epsilon r is 2.2. Then compute. Now here we are also talking about the reflection. So parallel reflection, perpendicular reflection, for theta polarization, for like horizontal polarization and vertical polarization. So here we can see the standing wave pattern generated. So when a particular media or when this So when there is a mismatch in the signal, mismatch in the material property, the transmission and reflection phenomena happen, and because of this reflection, the standing wave will be generated. So we can see the standing wave pattern generated at the left side as well as inside this particular body. There are also different experiments for oblique incidence and so on. For example, suppose we want to have an oblique incidence. So I will click on this and I will make this oblique incidence, let's say 20 degree or 30 degree, any angle we can provide. So this is like 10 degree. If you want to increase, we can increase also like 20 degree. So now this incidence will be oblique incidence. So how will be this oblique incidence things will work? So that also about the oblique incidence. So we'll compute it. So now here we can see these reflections coming out when this particular signal hit at different. I will increase this dimension. You can see this signal will go like this. It will hit here, then get reflected. Some part will go inside, again hit and get reflected. Let's say 9. So what will happen? We'll compute. So we can check out how number of cycles are going to change inside this particular media. Then how this Snell's law effect means the angle get tilted, the signal get tilted when it goes inside. So again, we can have multi-layer dielectric also. We can increase any number of layers we want, and we can also make some lossy dielectric, and we can find out how the losses happen, what happens when the signal gets inside the lossy media. So lot of possibilities are there. We can study any problem of basic electromagnetic by using this tool. So I'll just go to some examples. Yes, so starting from coordinate system, computing different vector algebras, vector fields and calculations over the vector field. Then there is also a chance that we can verify the Stokes theorem. Like in the left image, we have calculated the contour integral, which is 308, and in the right image, we calculated the surface integral of the curl vector over the same circle. So that will be 312. So both the integrals are almost constant, almost same. Then when we see the Sediku textbook, there are like many examples, and we have verified so many examples of Sediku book with the simulator. So for example, on page number 120, there is a problem statement that the finite sheet where x is changing from 0 to 1, y is changing from 0 to 1, and z is 0 has a charge density rho s is equal to xy multiplied by x square plus y square plus 25 to the power 3 by 2. Then find out the total charge on the sheet, the electric field, the force x by minus 1 millicoulomb charge located at 005 at a given point. And we verified these values also. So whatever the value we are getting from the software is equal to the. So we are going to offer like complete solution of Sediku, Poser, Balanis entirely by using this particular platform. So I will also demonstrate few more examples in the antenna design. Like there is again waveguides, many more tools are there like field analysis of parallel plates, cable. Then we can simply draw this type of cable. Like here is one randomly drawn cable, there is second cable. So let's say this is 0 to minus 50 to 62. So I select this cable, assign cable of characteristic impedance 50. Then there is another cable of characteristic impedance. But when we put a resistor at this particular side, a resistor of 72 ohm, then what will happen? the standing waves are reduced on the switch 72. Similarly, we can draw current distribution. Then we can see the S parameter also, the Smith chart. We can change the frequency and we can plot these results once again. Let's see. 5 plus 5 or 2021 mode or I have those examples. There are about 60 examples that are there in my laptop, so I can show those examples also. Few example I will show, but if someone needs contact you and addition pattern like scale, linear decibel, directivity total, directivity theta, phi, axial ratio, xy plane, yz plane, rectangular plot, polar plot. So there are a lot of options of drawing this radiation pattern in different ways. We can also see the field lines, how this field will look. That things also we can visualize. So mostly all the options which are there for antenna designs are available in the software. So we can design any type of antenna and we can simulate it at dB. So no reflection and no coupling. Then we solved a patch antenna with. So this is like a screenshot of location on this body problem or phantom approach. So this is mostly offering them the researcher can it the existing algorithm and they can solve most complicated problem and get that is also possible. So in the UI there are slider functionality, coding functionality. These are like 4 unique points which are available.
Point of time they have to visualize the things. More questions, you'll be in touch with us, sir. So
Did 3 days hands-on practices also, and even after 3 days, like completely 6 hours every day. After that also, many participants are saying that there are a lot of content to be covered, even after having like 6 into 3, 18-hour session.
exactly, sir. At least we will plan at least for 5 days FDP for the faculty and 5 days workshop hands-on with the students also. In soon we will be in touch with you.
Okay, sure, ma'am. So it is possible to design.
Request Dr.
One more query is there.
Yeah, sir. Sure. Yeah, request John sir. Yeah, just read out the query, sir. John sir.
Sir, is it possible to design the finite unit cell model and simulate using TARANG, and is it able to test in software using horn antenna?
Yes, we can simulate unit cell, but when we simulate unit cell, it is not required to test using horn antenna because in practical life we do the testing in horn antenna. But in case you want to draw the horn antenna also, then that is also possible. But the result that we want is by using the port. There is a different special port that we made for metamaterial and surfaces. By using that port you can do, that will be more easy.
Sir, I have a query.
So that model will the value of inductor, capacitor, everything. Like this inductor notation is L to 3.
Name, sir. Okay, sir, thank you.
Thank you, sir.
This event. I have seen your name and I recalled the moments.
Yes, sir.
And they can.
Okay. Your number, sir.
Okay,
So
Jones. I have your number.
Yes, sir.
Yes, I will. Yes. I will send you my number. Since I have your number,
Yes,
I will text you.
Yes, okay.
Okay. Thank you.
Yes, sir. Thank you very much, sir. Yes, sir. Okay, sir. Okay. Sir, you just start the conversation and